Hi, this is Abriana Carlton, and this is my PowerPoint slide for the poison dart frog. Poison dart frogs are vibrant amphibians of the animal kingdom that belong to the phylum Chordata. Their genus translated means dendrodate, which is a reference to the dart frog's arboreal nature, or tree-dwelling or tree-climbing nature. Their non-webbed, sticky toe pads allow them to grip and climb vegetation, including bromeliads and rainforest vines, where they transport tadpoles up into tree hollows or water-filled leaves to raise their young. They are found in the rainforest of Central and Southern America, where they flourish due to the diverse microhabitats of leaves, trees, and bromeliads, and also the humid climates that define this region that helps them to thrive. Some defining characteristics of the poison dart frog are its small size, with most species on average growing up to about 1 to 2 inches and weighing about 1 ounce in adulthood. Despite their small size, they stand out due to their vibrant color and pattern. They're also well known for their brilliant adaptive defensive mechanisms, which help them avoid predators. Poison dart frogs are some of the most devoted parents in the amphibian world. After the female lays her eggs on a moist leaf, it's the father who takes on the job of guarding them, keeping them wet and safe from predators. Once they hatch, he carefully carries each tiny tadpole on his back to a small water source, often a pool in a bromeliad plant high up in the trees. But those little pools don't offer much food. That's where the mother returns, laying unfertilized eggs as a special meal for the developing tadpoles. This form of parental teamwork is rare among amphibians and helps ensure that their young survives in nutrient-poor environments. It's one of the most remarkable examples of cooperation in the rainforest. Poison dart frogs don't rely on camouflage alone. Instead, they use aposematism, bright, eye-catching colors, to warn predators that they're toxic. These color patterns are actually honest signals. Researchers have found that the brighter the frog, the more toxic it tends to be. This is especially effective on birds, which are key predators in these ecosystems. Interestingly enough, some frogs even blend in from a distance, using what's called distance-dependent coloration. Up close, they're a warning, but farther away, they fade into the forest. And with their non-webbed, sticky toe pads, these frogs are built for rainforest life, easily climbing leaves and branches to stay safe and mobile. The toxins of poison dart frogs are among the most powerful in nature. Their skin contains batrachotoxin, a deadly compound that disables nerves by locking open sodium channels. This causes paralysis and even cardiac arrest. One species, the golden poison dart frog, holds enough toxin to kill 10 adult humans. Indigenous communities, like the Choco people of Colombia, have used this toxin for generations on the tips of their hunting darts. It's this incredible chemical defense that gives the frogs both their name and their fearsome reputation. What's fascinating is that poison dart frogs don't actually produce these toxins themselves. Instead, they get from their diet. In the wild, they eat alkaloid-rich insects like ants and mites, which carry toxins from plants they consume. These chemicals build up in the frog's skin, creating a defense that's both powerful and entirely dependent on what they eat. Frogs raised in captivity on crickets and fruit flies don't become toxic, which strongly supports what scientists call the diet toxicity hypothesis. You might wonder, how do poison dart frogs survive their own poison? The answer lies in their genes. Over time, these frogs evolved tiny changes in the structure of their sodium channels, the exact channels that their toxin targets in predators. One key mutation swaps the amino acid asparagine for threonine, making their own cells immune to petrotoxin while keeping the channels functional. This adaptation evolved multiple times in different species, and researchers are now studying it to learn how similar mechanisms might design future medicines. Although most animals avoid dart frogs, one predator can take them on, the snake Lamidophis epinephrus. This snake evolved resistance to petrotoxin by modifying its own nerve receptors. It's a rare example of co-evolution, where a predator adapts in response to a prey's defenses. While the frog's color and toxins keep almost everything else away, the snake shows that no defense is foolproof. In nature, evolution is a constant battle of adaptations on both sides. Despite their chemical defenses, poison dart frogs are facing serious threats. Deforestation and human expansion are shrinking their rainforest habitats. Climate change is altering the moisture and temperature levels they depend on. And the chycrid fungus, a deadly skin disease, has been wiping out amphibians around the world. On top of that, illegal poaching for the exotic pet trade continues to hurt wild populations. These frogs may be toxic, but they're not immune to the effects of human impact. Poison dart frogs play a key role in their ecosystems. By eating insects, they help maintain the balance of rainforest life. Their presence supports biodiversity, and their sensitivity to environmental changes makes them powerful indicator species. When dart frog populations decline, it's often a sign that something much larger is wrong in the ecosystem. Protecting these frogs helps protect the health of the rainforest as a whole. Thankfully, efforts are underway to protect poison dart frogs. Conservationists are working to preserve their habitats through protected reserves. Captive breeding programs help ensure their survival and maintain genetic diversity. Laws against illegal wildlife trade are being strengthened, and public education is raising awareness about the value of rainforest ecosystems. Saving poison dart frogs is about more than just one species, it's about preserving the rich web of life they're part of. Thank you very much for watching my presentation, and this would be around the time that I would open up to the classroom for any questions. And here are my sources. Thank you.